Moving into lesson 5.6, we're going to take the same skills we learned in lesson 5.5, but now we're going to apply it to our system of solving systems of linear inequalities. So I tell us that we're going to graph the first linear inequalities boundary line and shade the solution region light red. Yes,
I have a question. So since none of them have the y by itself, would we divide, like for the first equation 2y, would we divide all of them by 2?
yes. We are going to still have to put them in slope-intercept form. So, but listen to me carefully on this. Do them one at a time on the graph, okay? Look at the first linear inequality in the system. Do everything as if it's the only one involved. Just graph it, shading, do everything you need to do, and then go and do the second one, maybe the third, the fourth. Today we only have 2. Do them one at a time, independent of each other. So then it says, now graph the second one and shade that solution region lightly. Then it says, the solution for the system is the region that is shaded twice. When we just have 2 of them, there's going to be, we've been shading. If there's any region that has been shaded over by both of them, what we call the overlap, that's our solution region. So we have got to make it very clear what our solution region is, and we'll talk more about that. Okay? Yes, Clara?
So when we're dividing, we change the sign.
I don't know. When do we change the sign, class?
Positive and negative.
When we're dividing by a positive or a negative? Which one? A negative, yeah. When we're dividing by a negative. So let's do our first one here. 2y is less than or equal to negative x plus 6. What are we going to do to get it in slope-intercept form? Yeah, divide every piece by 2. Okay, so we'll divide every piece by 2. And now we'll have our y alone. Did we divide by a negative?
No.
No. What's negative x over 2 going to become? I think it's negative 1/2 x. Yeah, not negative 2x, negative 1/2 x. And plus, what's 6 divided by 2 is 3. Okay. So we can say our slope is negative 1/2. We can say our y-intercept is 3. And we're going to go graph that one. Okay? Should that boundary line be dashed or solid? Solid, because what? Has the equal to bar. Okay, so go ahead and get that boundary line graph, please. Graph the boundary line for this one. Should our boundary line be rising or falling?
Falling.
Falling. Okay. We're going to predict where we think we should shade, and then we're going to pick a test point. Where do you think we should shade this one?
Below.
Below. Okay, let's test to make sure though. Okay. Let's not set ourselves up for failure right away.
0.
So what do you want to test?
0.
Because why?
It's below the line.
Because it's below the line, but also it's the easiest and it's not on it's not on the boundary line. So as long as it's not on the boundary line, it's safe to test the origin. So where do we test it though? In our renamed or in the original? In the original. And plus, by the way, it's easier to do it up there, usually. Today it's not in, this one is not in what we call standard form. I get 0 is less than or equal to 6. That's a true statement or a false statement? It's true. So true tells us that the origin is in the shaded or not? It is. Okay, so now we are going to shade lightly below. Okay, and sometimes it's a good idea too. This is that assignment I said you could use colored pencils, but the only problem with colored pencils is erasing them sometimes. But if you want to use colored pencils in your homework, feel free. That can be your call. Now, what I was going to say is too, the other thing that helps is sometimes the direction. So if you shade this one all in the same direction, And it helps when you shade the other one, you can shade it going a different direction, you can kind of see the cross hatching or the overlap a little bit easier. Okay, let's go on to the other one. We have that one done. We always want to make sure this one's done before we move on to our other one. Okay, so our other one is the negative 3x plus 4y is less than negative 8. Is it ready to graph? No. Okay, go ahead and get it ready to graph. Because you know how. What do you feel about our boundary line? Should we make it solid or should we make it dashed?
Dash.
You need to make it dash now. You're putting two boundary lines on a graph. You gotta be able to tell. Whatever you're gonna do to make sure that one of these is solid, the other one is dashed. So we gotta make sure we can tell that. As these graphs get busy. Should our line be rising or falling?
Rising.
Okay. Make lots of points, you get some good boundary lines. And make sure those boundary lines go all the way through your graph. Don't get stingy with them. Yep. Why did this get negative? Don't use negatives. Should this one be shaded above or below? What do you think?
Above.
Below. So are we going to test the origin again? Yeah, okay, test the origin. But then it should test what?
Above.
Because we think it should be shaded below, so it's the origin's up here. Remember, we're testing the origin in all of these cases, it looks like. So should it be false, true or false then? Should be false, shouldn't it? Okay, so let's test. 0, 0, and see what happens. And in the original, remember, don't be doing it in the renamed, because you might have renamed it wrong. I got 0 is less than negative 8. True or false? 0 is larger than negative 8, isn't it? So that's false, which verifies then that we should not shade that side. We should shade this side. So now, this is where you're kind of forced to go a different direction, almost, but go a different direction. Okay, now we have to have an understanding of where are the solutions for this, okay? There are an infinite number of them. We can't begin to name them all, but we have to understand which ones are on this graph and which ones are not, okay? Because these two are working together, okay? So what you're going to do is you're going to take your pencil now and you're going to take that region where there is double shading going on and you're going to triple shade it. You need to make it stand out that that is your shaded region, okay? So I see that I have my red and my blue in this bottom, like upside down V part. So this is where our triple shading is going on. Is right in this, our double shading is going on, and we're going to triple shade it so that we can tell. It has to stand out. When somebody looks at your graph, they should be able to tell very easily where your solution region is. If it's on it, so if you shade either of the other ones too dark to begin with, it makes it harder to make that region stand out. That's why I said shade lightly for them. And in reality, what this region looks like, and it should be very clear on your paper, it is like there. It's below this. This is where it's at. It's in that shaped region. It is not off to the side here. It is nowhere above it. Now, anything in that triple shaded now region, that overlap region, is considered a solution. But now we need to talk about which of the ones on the boundary lines are. Because there's some boundary lines that are right here. This is, in fact, I should probably make this one a dashed one to make my point. So this boundary line of our region, I need you with me. This boundary line, right here, this boundary line of our region is dashed. Can any of the points on that count then for our solution region for the system? No. Any dashed lines, points on dashed lines do not count as solutions for a boundary, for a linear inequality. So these cannot count for this system. Okay? Even though they're really in the red shaded region, they're not also in the blue shaded region for me, so they can't count. They have to satisfy both. How about this point right here? Right here is where the kind of like the top of our shaded region. Let me make that a black one so you can see it. What about that point right there? So it's really this point right here. You know, the one that showed up on both of them. How about that point right there? Is that a solution to the system, do you think? It's an intersection point on the boundary lines. Could it count? Because one of the boundary lines is dashed. So it can't count. If they were both solid, it could. But because one of them is dashed, it can't. So that point is not a solution either, just like none of these other guys along this dashed line are. But how about these guys that are over on this part right here? What about this line? Yeah, because it is solid. So the points that would fall along here, like this one right here. 1, 2, 3, 4, 5, 6, 0. 6, 0 would be a solution to the system because it's on the, you know, what we kind of call the margins of our double shaded region, or triple shaded maybe, I guess. And because it's on a solid boundary edge, it can be considered a solution. So we have to have an understanding of where the solutions actually at in these. So when we apply them to word problems, we understand it. Okay? Any questions? Look at your table partners, and Aurora, you turn over with these guys. You look at their paper and you see, can you clearly tell where the solution region is? I'm seeing some incorrect solution regions, so you guys better help each other. Yeah. You and I should be able to tell. Okay, so should this be part of the solution region, Tony? And is it up here on mine? Did I keep shading? Did I keep shading up here?
No.
No? No. So can you tell on stand up? Yeah. See, when I just look, I should be able to look at your papers and I can say, oh yeah, they can clearly tell their solution region.
So this is my point range.
Now I can, now that you erase that.
Well, did you see what I wrote?
No, I don't really want to know what you wrote in there.
No, it says point range.
Oh, solution region?
Yeah.
Okay, gotcha.
Point range.
Would you help him out there? He just is happy to just leave it. I don't think he should. Okay, let's go to the back side and do number 2 together. Okay, we don't have a whole lot of room here, so let's do this. Let's make it so that we're going to work with one on one side of this line, and we're going to work with the other one on the other side of the line, okay? Let's do it that way. So we are, so we're going to work with 6x minus 3y is less than or equal to 12 on this side, and over here we'll work with the other one. Okay, one at a time. Let's take care of that 6x minus 3y is less than or equal to 12. Let's get it in the slope-intercept form. cautions, subtractions work better when we change them to add the opposite. When you are done changing the first one, before you even move on and do anything else, I want you to look up and see if you agree with me. Do we agree that the y-intercept is -4?
Yes.
Okay. Do we agree that the slope is 2?
Yes.
Okay. Do we agree that the inequality symbol needed to reverse? Because why? Because we divided by a negative. So that's really important. We have to make sure that we take care of that. Okay, so we're ready to graph our boundary line. What is our boundary line going to be? Solid or dashed? Solid. Okay, go ahead and graph it. Should our line rise or fall?
Rise.
Rise. We always ask ourselves that question to save, making that silly mistake. Okay, test point. Can we test the origin? Sure can. Okay. Okay, now I'm gonna let you I'm about ready. I'm finally in, a generous mood. If it is, the original inequality is in standard form, what does standard form look like? The x is
ax plus bx equals
ax plus b,
y.
y equals
c.
c. So in other words, the x's and y's are on the same side and the constant's on the other side, right? Whether it's an inequality or it's an equation, that's how standard form is. So is our first equation, remember, because that's where we tested, is our first equation in standard form? Yes, it is. It's got the x's and y's together. So when we get to use the origin, which is what we're using, we're testing the origin right here. When we get to use the origin, what should happen right away? 6x minus 3y is less than or equal to 12. What should happen when you put zeros in here?
0 plus 0.
Yeah, you're going to get 0 plus 0. Just go 0 plus 0 is less than or equal to 12. 0 is less than or equal to 12. We're not even going to show the substitution steps. We're going to be like, seriously, we're going to multiply by 0 both times. We have to get 0, don't we? Is that true or false?
True.
True. So that means we should shade above. And is that what you think should happen?
Yes.
What happens if you look at it up here? Before you got it in standard form, or in the slope-intercept form? You might think you should have shaded where? Below. So where do we make that decision? When we're doing the above-below decision, where do we make that decision?
Or into slope-intercept form.
After it's into slope-intercept form. Look at here, it got moved to is greater than, that's why it turned out above, okay? So go ahead and shade lightly that side. And then we will move on to our second inequality. So go ahead and get that one started after you're done shading. After you've got it renamed, you might want to just double check and either catch me if I make a mistake or yourself before you graph it. probably erase a little easier on here than you can. Like right now. Shoreline rise or fall?
Rise.
I don't have this right.
Well, thanks for speaking up. Saved me some. Oh, were you so? You didn't yell at me, LeBron.
Okay. Oh, finally. Okay. Try this again. Solid or dash line?
Solid line.
Okay, yeah, you guys gotta take care of me. You just discovered that, right?
Yep.
Okay. Oh, what's true about our boundary lines? Parallel, why are they parallel? Have the same slope and different y-intercepts, okay? Where do you think this one's gonna be shaded?
Below.
Below, where's below? To the
To the
right?
right of it.
Okay, so we'll test 0, 0 to make sure, okay? So we'll test. This one has the x's and y's on the same side, right? It's 2y minus 4x is less than or equal to 6. So this is going to become 0, right?
Yeah.
This is going to become 0, right? Okay. 0 take away 0?
0.
True or false?
True.
True. And you said we're going to shade below, and the origin's right here, and that is below, so we will take our pencil now and we will shade below that boundary line. Is there any part of our graph not shaded?
No.
Is there any part that's double shaded?
No. Yes.
Where at?
Then between the 2 lines.
Between the 2 lines, I call that a runway, right? It's shaded in the runway. So take your pencil and triple shade now.
The runway.
The runway. Mm-hmm. Mine's going to be in red. That's where both of them they are shaded, and that's the only region between the 2 boundary lines. So any ordered pair that is a solution to this system of linear inequalities has to fall in that shaded region or where else? On which boundary line? Both of them. Both of them, yeah. They're both solid, aren't they? They're both solid. So any point on either boundary line and any point in that runway, in that overlap region, is considered a solution to this system. Over here, what is my blue region, that should still be light on your graph. What is my green region up here should still be light on your graph. The only thing darkened on your graph should be this strip. I look at your paper, I better be able to see that. Okay? And again, we have to make sure we can clearly tell that the boundary lines are solid. Don't shade so much that you get, especially dashed ones, don't get so close to them that you can't tell that the boundary line is dashed anymore. Okay? You have to be really careful about that. Anybody have any questions?
The part where, I know the middle is like triple shaded, but how does the blue part get shaded?
The blue part got shaded because we tested 0, 0, and it tested true,
Oh,
and the origin is right here, and so we had to shade.
all of them?
Yeah. Remember, this is the one that the boundary line's the one to the left.
So we shaded below it, because, and the other reason that we were pretty convinced we would shade this direction, because that would be below. And then the origin right here did test true, and that's it's to that direction from that boundary, okay? Okay. Anybody else? Don't lose these notes, because we're gonna finish them up tomorrow, and you're also should be using them to help you with your homework, right? So you do not need your book, but if this does not allow enough room for you to show your work, you might want to get out loosely, otherwise you can show your work right on here, like we did in our notes. We're gonna do that tomorrow.